Okay, so now we will talk about the next subject. So what I'm going to show you is that how you can connect your legacy system with FIWARE. So now why we are talking about smart cities today is because it's just an example, because I work usually, this is the case I use, but you can definitely use it for your botnets, for instance. You can create a data model for botnet. You can collect the data, and then you can apply some analytics and predictive analytics on top of it to study it, to study the attacks, and you can have some statistics on top of it that you can easily do. So, but we talked about that you can easily connect with sensors, but what if you have a legacy system, okay? For instance, I'm here using Google Maps. So what I'm going to do is that I'm going to read some data from Google Maps, specific data, and then store it on my context broker. After that, what I'm going to do is that I'm going to query the context broker, what I'll do is I will do some geolocation queries. Geolocation queries means, like I would like to see what places do I have in 11-kilometer radius from here, or what is the nearest coffee shop, like that. So nearest, this kind of application. So what I'll do is that instead of depending on Google, I will just pull the data from Google, some data, so that I just can show you the capabilities. Now you'll see that you'll think that you have already data on the Google, but what if you want to make your own application independent of Google? And what if you have your own set of shops and set of different kind of location, and you want to keep that data in a geolocation format? You can definitely do using FIWARE. So let me show you the demo for that. Okay, so here is an application that I have developed, okay, tailor-made for this kind of trainings. So I've used the language called C#. So do some of us use C# here? .NET? Okay, so it's a Java-like language, okay, and it's very easy to follow. So let's see what I've done here. So a program, and the point of start of the program is from main. Like I think most of us know about this. So the entry point of your program that you write, is from main. So here you can see the main here, okay. What I've done is that I've tried to find some places. So I found that in Philippines, when I Googled also, so I found that there is Manila, there is Boracay, famous places. So I'm trying to find where I can go in these places. So what I'm doing is that I'm trying to gather this information into my system. And then Gurgaon is the city where I live in India. So it's where my office is. So famous places there, and Delhi is very near to Gurgaon. It's just like 0 kilometers. So they are like touching each other. So famous places in Delhi. So what I've done is that I'm trying to gather all this information, then I'll put into my system, and then we'll do some queries on top of it. Okay? But the queries will not be on Google, it will be on your own data. So here you can see, now we'll talk a little bit about data models, okay? What they are like before I go further in this demo. So the FIWARE data models, as I told you, that everything that you define, like weather observed, or you define, let's say, air quality, you talk about bus, you talk about train, you talk about anything, has a definite way how you represent that, okay? And it's available open source. So there are some bodies, they work on it, that how in a smart city scenario, how will you define your data? Now just imagine the one of your city defines a data model of a street light in one format. For instance, it uses the word, let's say the street light has what? The brightness level, Let's say you're making a street light, and there is a street light in one city, in another city. So one uses the word brightness, and another one uses luminosity, maybe something like that. So you will have no common, how will one city talk to another city? It won't be possible. And what we have seen is that if you don't follow common standards, you might be facing a 70%, up to 70% loss of revenue because you're not following the same kind of standards. So where are these standards defined here? So I can just go to just Google FIWARE data models. You will find some data models here. Okay. So where do we want to go? Let's take waste management. We talked about waste management briefly. Okay, so waste management. So there is a waste container. Let's see this. So this is a model for defining a waste container. So if you want to make a waste management service, you need to define a waste management, waste container data model. So how it is? It has an ID. ID, as I told you, is mandatory. Type is mandatory. So type would be waste container. Then the source, okay? So maybe the source is your own sensor, or maybe you're getting the data from some other API. You can use source. Then location, the location of your waste bin, the address, the filling level. So you can also see what we have defined here is that location should always be defined in this format, RFC 7946. So in these data models, like you can, it's very, very unique. I mean, you can see if I go here, so location should always be defined in this pattern. So you can refer and you can use the same data standards everywhere. Then the filling level. So you can also see the units that you need to use to express that. Okay. Fullness threshold, the cargo weight, temperature, methane concentration. So the waste bins have a lot of methane, and methane can be very dangerous for the workers because it captures fire. So if there are some sensors applied on top of it, it can monitor the level of methane on top of it. So you can see there are many such attributes. Okay, so you can see that some of them are like mandatory. You should have them. So this is standard. Or some of them are, let's say, not non-mandatory. So optional. So you can have both. So this is a standard one, which is actually we are referring here to Gsm Standards. We follow GSMA standard. As I told you, we follow usually GSMA and ETSI standards. So this one is coming from GSMA. So even you can also go to GSMA website and you can you can also see the data models here as well. Okay. Okay, so this is similar to that. You have a point of interest, okay? Here it is. So point of interest is used to define the point of interest. Means, let's say, a particular location, maybe a museum, maybe it could be anything. It's a generic object to represent that. So here we'll use the point of interest data model, okay? So it has ID, type, category, description, source. Source means from where you get this information, so you can define that. The location of that point of interest, a museum or church or whatsoever. The address and the name, okay? Now if I go here, okay. So when I get the data from the Google, it's not in the standard format, okay? we want the data to be stored in a standard format. So it's coming from a legacy system, so it's not standard. So in order to get it convert it into standard format, what we can do is that we can write a translator, okay, program to do that. Now let's see what kind of data structure that we get from Google. So Google uses Google Places data model, and it looks something like that, okay? Formatted address, geometry, icon, opening hours, and this thing like that. So here I've defined the data model in my source code, which is in the Google's format. And then I can what I can do is that I can translate into point of interest. So this is the point of interest data model, which has an address, category, like if it's, what is it? It's a museum or it's a zoo, what is it? So you can define a category. The description, you can add the location information, what is it, where is it? The name of the place, the source from where I got the information, and the icon, ID, type, the temperature and inception date. So temperature and inception date are not part of the data model. This is just to represent that you are free to modify the data model as well, okay? So for instance, if you have something which is a very unique use case, as I explained you in the last session, transformer, okay, transformer theft. So we did not have a data model for that. So we defined our own data model in that case, taking the reference of other data model which we already have, and we improve the data model, and then we report it back to the open source community so that someone else could use the data model as a responsible open source contributor. So here I've just added temperature and inception date. So just to tell you about that, you can add even more data, attributes if required. Now if I go back to main program, so you can see I've array of these different strings, and what I'm trying to do is that I'm trying to read this array one by one, okay? And I'm doing a search at Google. So here is a method. I can go to this method now. So here is a search string, and I'm using the Google API here. And here I'm getting different pages from Google. I'm trying to grab all the data, okay, and then I'm returning back the results in the Google format, which you can see here again. Okay. Once I get the data in one format, okay, I need to translate the data into a standard point of interest data model, okay, which is a standard data model. You know, that should be. So what I did is I write this program called translate to POI. So it's doing not much. If I open it, it's an easy function. It's not difficult function. So what it does is that it's just translating the data coming from Google into the standard data model that we have with GSMA. You can see this, what I'm doing here. It's just a simple translation job. If I move back now to my program, then what I'm doing is that I'm just collecting all the data from all these 4 places, and then I'm trying to create the entities for them, okay? So it's just that what we're doing is that we'll do post one by one to all these places, and we'll store them on our context broker. Now, where is my context broker? I did not show you where I installed it. So for your information, I pre-installed it, okay, on my cloud, and I'm doing a post there, okay? So, does anyone work on databases? Anyone? Databases? MongoDB? Anyone MongoDB? Okay, so it's so MongoDB is a document-based database. Okay, so it's actually provides you very fast read, at least. So the context broker is a program which is written in C++, and you can see the source code. It's available online on internet. It's open source on GitHub. It uses Mongo as a backend. Okay, so if I open here the database, okay, so you can see there is a collection. So collection is just like a table. You can relate. It's not exactly table, but you can relate to as a table. So it has entities, and here so whenever you create an entity, here is how it's stored. So I did a test when I arrived in this training. So there is already data in this context broker. So what I'm going to do is that I'm just going to drop this database so that I can show you the demo. So now the context broker is empty. Simple as that. So it's empty. So there is no collection currently in the context broker. So no collection means no entity. It's empty. So what I'll do is that I'll run this program to create the entities of famous places in Manila, Boracay, Gurgaon, and Delhi. Let me run it. So currently it's doing a Google search, so it takes some time for doing the Google search. After it finishes Google search, it will start creating entities, and you will see something popping up on this black screen. So you can see that your entities are getting created now. Okay, these are different places. So I've just, you can see that they are created. Some are church, some is museum, zoo, and different places. So let it first create. So here you see that we're getting an error here. It's because the Google sometimes provides us redundant records. So those records which are redundant are being rejected. You can see you get the message already exists. Do we have a question? Meanwhile, it creates, do we have a question? Okay, meanwhile, can just show you the program. So you will have the access to this project when you will get your content. Now, I'll also show you meanwhile how you can traditionally, while it is being created, the entities are being created. I will also tell you about how you can traditionally test your API, context broker API. So for that, you could use a tool called Postman. So for those who are aware of REST API, it's a very, very common tool. But I use Visual Studio Code because I can store all this, all of my queries, and I can put them on Git easily, and that's why I prefer to use this. Now you can see, as I told you, that in order to check the version of your context broker, you have to do /version. So I click on send here. So this is the request, and you can see on the right the response. Okay, so its version is 2.0.0 next. So you can see who compiled it, what was the date, and so on. So you can see this details. It's kind of a metadata for context broker. You can see its version, and you can also know that the server is up and running. Now let me see if, meanwhile, if the program has successfully. So you can see that the program has done its job, and it's created all the entities. Now, I would like to do some geolocation queries. I showed you some queries when we saw our room example. You saw some queries there, like I wanted, what are the rooms which have temperature greater than 24, or what are the rooms which have pressure between 715 to 725 bars. So there you can also do what we call as geolocation queries. So what you can do is that you can have things like this. So you can define /v2/entities, ID pattern equal to .star. So you don't want to, you can also use regular expression here, okay? So the context broker has a lot of capabilities for any kind of queries that you want to make. So you can also use a regular expression. So ID pattern .star would mean that all the entities, okay? Type equal to city. So I want all the cities, okay? Georel equal to near, and max distance 135,000, which means this many miles. So I want all the cities in this circle, and geometry equal to 0.10%, and these are the coordinates. So I want to list all the cities which are in as taking the center as this at this coordinate. I would like to see all the city in this between 13 kilometer of radius. I think it's in meters, and so I can know. So similar to that, I can have georel equal to near. I can have georel equal to far, which is like outside that circle, just outside the circle. Then I can. There are a lot of options. Like you could have covered by. You could have intersection. You could have a disjoint. So let's say you have a region, and you would like to see all the points, geographical region, I mean. And you would like to see all the point which intersects that region. So you could apply a query like that. Or all the set possibility in the set theory, you can use covered by, intersects, equals, and disjoint. You can define either a geopoint. So for instance, the museum is a point. It's a point. You can draw it on the map. So it's a point. So you just define the coordinates of it. But let's say if you're making a smart farming application, you would want to define your farm, okay, which would maybe a square or maybe a polygon or maybe what we call in GeoJSON. So you can define that GeoJSON and you can represent your farm in form of, let's say, GeoJSON or even GeoPolygon. GeoLine is for showing a road, maybe if you would like to show a road which is like a line, or you could also represent a box, okay? So as all these entities are created, so what I've done is that so this is the coordinate of the location we are sitting, okay? So let me just show you this query. So first, I think I did not show you all the entities, okay, which is created by my program. So not to worry, the program that I have written is just doing a post, nothing else, okay? Just doing a post of whatever it gets from Google, it just posts on the context broker here. So on the right, you can see that these are the data that I've collected, okay? So there are total 100 in the header. You can use options equal to count. It's a option that you can use if you would like to count the number of entities that you have. So you have 173 records, which means you have 173 entities. So this is how it looks like, okay? The different entities collected from all these 4 regions, okay? You can see. There is also a special option called key values. So here you see, every time I see here, I have the type, the value, and metadata, okay? So what if I just want, I don't want this type, I just want to see the value, I just care about the value. I want to have a, let's say, more shorter, concise view. So what I can do is that I can do option equal to key values, and what it's going to give me is something like this. So easy, it's more readable, I think, for you. You can see it's this one is a museum. You can see its category, inception date, location, name, and so on. Don't focus on inception date, it's completely random, okay? So I just showed you as an example. Okay, so what if I want to visit some place in Philippines and I would like to know what are the good places in 11-kilometer radius from here, okay, where I can go, because you have a lot of traffic. So I would like to make a visit to places which are nearby, so that. So what I've done is 11,000 max distance, and I have geometry point. This is coordinates, and I'll try to see where I can go. Okay, so there's a church here. You can see the name. So Saint Sebastian Church, I think. So you can see that this is there are some percentage and these kind of strange characters in between. So it's because of the reason is that for storing such information in the context broker, there are some characters actually which are reserved characters. So what you do is what you call as URL encoding. So you have to encode it so that you can store it in your context broker. So it's just encoded. In your program, you can easily decode it, okay? So it's stored in, but you can still understand what place it is. So similar that you can see there is a minor basilica, there is another church, There's another, what is this? Okay, it's Mystery, Manila, Jupiter, Makati. So you can see there are a lot of places that I can go. Really a lot of places. So, okay, I'm happy. So there are a lot of museums, churches, and there where someone can travel. So you can see that how easy it's to collect the data from. So don't worry, you will get access to the source code if you want to see it by yourself. So you can see how easy it is to do such kind of operation. Now, as I told you that there is an option to, in your context broker, to store, let's say, a two-dimensional, like a road, if you want to represent a road. How do you represent a road? So road, again, we'll talk about data model now. So road has a way, as a standard way how you represent a road, okay? So this is the way. So type should be road segment. Category two-way, that means the road allows you to go in both directions. Allowed vehicle types, so some roads, they are restrictive, so it's enumeration. So some roads are restrictive, let's say they only allow smaller vehicles. So here, this particular road allows the car, bus, lorry, and van. Then location, so as you can see, this is the start point and end point, okay? Now, because of the standards, I also need to define start point, end point again, because I have to follow the standards. Then the name Faridabad Bypass Road. It's a place, actually, it's a road nearby my home, actually. So I've taken this road as an example. Max allowed speed, so 80, and minimum allowed speed is 40. So you can define the main speed, and some places, I don't know in Philippines, but some places in India, they have like minimum speed as well, that you cannot reduce the speed below that point. Then source, you can see the source that it's coming from Google Maps, and icon, okay? So I can, let's say, let me try to just click send request to create this entity, okay? I click send. So it's a simple post, and on the right you can say I get 201 created, okay? That means this road segment is created, simple. Now I just go down, what else I can do? Okay, so now these are the coordinates of Bermuda Triangle. So you can see it's a triangle, okay? So you can define, this is, let's say, the first coordinate. Okay, this is the second coordinate, third coordinate, and the first coordinate again to join to make the whole polygon complete. So it's a triangle. Don't confuse with why we define 4 format. It's just because of the standard. So it's like first vertex, second vertex, third vertex, and first vertex again, okay? So the type is geopolygon, and a type is triangle, okay? So let's create this as well. Okay. Similar to that, you can define a building, which is like a rectangle, start point and end point. So just start point, end point, you can define a box by just 2 coordinates, right? Let's create that as well. You get 201 created. If I move down, you could create a polygon, you know, a pentagon, like that. Okay. So, okay, it already exists. Maybe I created it before. So you know that if you try to create something which already exists, you get an error, unprocessable entity, okay? And you get already exist error. Okay. Any question until now? Does it give you an idea? Does it trigger an idea in your mind, like what you can create something for your home or maybe for your locality? I got to know that even Manila is, I think, the government is maybe, I think they're working on a smart city here. Not sure, but maybe they're working in a smart city application development here. So what I'm going to do is now is, let me just show you this on a map. So how do you show it on the map? Okay, so now I'm going to use Google Maps again, but do you know about OpenStreetMaps? Do you know about OpenStreetMaps? Okay, so OpenStreetMaps are like open source maps. So Google is like paid thing. Okay, you have to it's free for some use, but if you want to make more API calls, if you want to use it for commercial use, then you have to pay to Google for that. So OpenStreetMap is open, but for the demo, for simplicity, I'm using Google Maps to represent. But otherwise, for your research application, you can still use Google Maps. But for instance, for a commercial application, you can, if you want to cut the cost, you can use OpenStreetMaps as well. Then there is something called UMap. Using UMap, you can host your map in your own server. Okay, so let me just open this one. And we should see normally a beautiful map of the world. Okay, so this is it. We are somewhere here, I think. So what I'm going to do is that I'm just going to do a query. So what I've done, let me just show you the program here. Okay, so it's a simple program, okay, nothing to, it's not tricky. It's just I'm reading from my context broker and I'm showing on the map, okay? So here you see my URL, FIWARE host. So why FIWARE host? Because I have mapped this in my local etc host. You know etc host? etc host where you can define the host and IP mapping. So in the Windows etc host, I've defined the IP. That's why you see a FIWARE host here. But if I, let's say, try to ping this, you can see the IP, okay? I just do a lookup here, you can see IP. So it's a context broker actually installed somewhere on the cloud, okay? Now, you can see here, I started a for each loop, okay? I am trying to read what I get from the context broker, okay? So I'm reading the entities one by one, okay? Then I am just, there is a attribute called icon, okay? So I just use URL LM, which is you can understand that LM means the entity that it gets in the loop. The first entity, second entity, and third entity, fourth entity, and so on, okay? So LM is specific entity in that, which is running through the loop, and you just get the icon here, and you just make this object, okay? And after that, what you do is that, similarly from LM, you get the position, okay, lat long 0 and lat long 1, okay, here, okay. So the location, I was storing the location as well. You can see, as I showed you entity, you saw it, that you could see the location. Now I made this marker, and I'm just using the Google API to just draw this on the map, okay. So it's all available online. You can see how you can do that, how you can do the visualization. It's very easy to do. Now if I go here, back to the demonstration, I think one thing I missed to tell you is that you can see what I did here. This is the URL of my context brokers up to /entities. What I did, I added this windows.location.search, okay? Now what I want is that whatever I put as a search query, it should go to my API, and that result I should be able to see, you know, in order to have a better demo possible. So I'll just copy this. So what is this query? Options equal to key values and limit equal to 1000. So that will do is that it will take out the top 1000 records. Now for a reason we know there are only 172 entities, but we just want to draw them on the map, okay? So we'll just copy this. And paste it here. Okay, easy peasy, right? So you just see here is Philippines. So let's first go to Philippines, okay? So you can see we are somewhere here, right? And this is Manila, and this is you can see. Let's go to Manila, and you can see all the places here with the icons. With the icons, you can see different kind of icons representing different. This is a church icon, so you can see different icons, seafood, so some restaurant. So you can see a lot of things. You can definitely click on it, and you can see the entities. You can see the entity here. Okay. So what I want to show you is that it's very easy to do these kind of things. So all uses Google API. The Google you can either use Google API, or you can also use OpenStreetMaps or UMaps as you want. Okay. Okay. Let me just show you one more example. What if I want the places which are nearby this place? Okay. What we did with query, let's see it on the map, okay? I think I pasted it 2 times. Okay, I'm running the wrong demo, I think here. This is the right demo. Okay, here we go. These are the places where I can go in a 11 kilometer radius drawn on the map. Very easy to do, something like this. Okay, so we did draw some points using the ingestion method I told you, the translator that I write. So you can do that, but you can also represent the road. So let me show you that. So for that, this is another demo. So you remember I showed you that I draw a road segment. So let's try to visualize this road segment, where it is. So you see there must be orange dot somewhere here. Yeah, this one. Okay, this is a road. This is not a point. So because it's so small that you cannot see it as a road. But if I zoom in here, yeah, it's a road segment. Okay. So this is how you can represent a road segment. Okay, and you can draw it on the map. Similar to that, the triangle. Okay, it should be this. Similar to that, you can do for the triangle as well. Okay, so you can do it the triangle, the box, and you can draw it like this. Okay, the API is available in all this open source as well as with Google or even Bing Maps. If you're into that, you can use any kind of mechanism to do that once you have the information stored inside. Okay. Okay, so what we saw is just the tip of the iceberg. Okay, the context broker provides So what we saw is the creating, pulling data, pushing data, subscription. I showed you about. We didn't talk about batch operation. So batch operation, I just show you. Just take one moment. Batch operation gives you the flexibility because there were like a lot of entities. Okay, like we made 172 entities. It took a significant amount of time to do that, right? Took like we had to stop for a while. So using the batch operation, you can do everything. You can update all the entities in one go. Okay. So I've written a method here. Let's see how much less time you can make. So last time we used the create entities method. So I did not show you that method, I think. So let me just first show you this method, what we are doing here, so that you know what's written in the program. You can see it's just post async. What we're doing here. So we're just doing serializing the object, and then we're doing a post. Now, if I show you the another method, which is create entities bulk. So it's just you need to define the action type as append, and then here you can define all the entities. I will also show it in the presentation. But let me just run this program to show you how fast it is. So the Google search takes some time. After that, it would be just quick and instantaneous. So meanwhile, no, let's see this. It should not take a lot of time. Any questions? Okay, so it's done. Okay, so it's much faster because what we did is that we took the results from the Google and we uploaded everything in one go, in bulk. Okay, so it's faster to do it like this. So it depends on the kind of application that you want to build. Okay, so what are other type of things that you can do? Pagination. So you can have some paginations. I will not go in detail. So you can have some kind of pagination. You would like to see, because if you have, let's say, millions of entities, let's say, then or thousands of entities, in that case you cannot see all the entities in one time. Okay, so you can do pagination also. You can start from first page, second page, third page, like that. You can have paged API. So Context Broker supports pagination. It also supports metadata. Now, what is a metadata? So you know that entities can have multiple attributes. Every attribute can also have some metadata also. Now, metadata is something. Metadata, as you know, is the data about data. So, for instance, here in the example, you can see the tire pressure can have here. This is not metadata. Sorry, I'll show you the example of metadata. It's not here. I'll show you the example of metadata in my demonstration. So here, this is the compound attribute example. So metadata is something, let's say you have a speed, okay? And you can define accuracy as a metadata, okay? Like what is the accuracy of your sensor? You can define in form of metadata. You talked about it, geolocation already. So I'll just move from here. Geolocation demo I've shown you. So this is the metadata which I was talking about. You can see accuracy of the temperature sensor. You might have some, plus minus temperature sensor. You can define it here like that. So as I told you, there's a 1:1 membership between entity and attribute. The same goes between attribute and metadata. Filtering, I showed you some example of filtering last in some of the queries. So you could have, You can filter by type. You can filter by ID. ID is room 1, room 2. You can you can have some patterns. So whatever I'm just telling you, I have run all these examples, and you will have access to the source code. So you can you can try everything by yourself. So in the code here, you can see on the left, there are many programs, small queries. So you can refer those queries, and you can try to run and test the things by yourself. Okay. What else? So okay. So here you can also filter by ID. So you can either filter by type. You just want rooms in the context broker, or let's say if you want the entities room 1 and room 2, you can do that. Or if you want some pattern, you want to apply some pattern that you want room 2 to 5, you can do that. Or you can apply the same for type. You can, the first example here I have shown you, temperature greater than 25, you want all the record. You can apply it for complex types. You can do even the queries on metadata if you want to do that. It also supports date time, okay? It's a special format for storing the date and time. So what you can do is that you can, it has some special attributes called date modified and date created. So these are the attributes, hidden attributes, so that if you want that when was your record last time created, last time updated, you always have access to that, okay? You can also do some queries as per the date time. Let's say you have the record of all the lecturers and students here. So you can do a date time query, and you can write, let's say, the birth date less than 1985, this date. You can do a date time query as well. So we have seen the different kind of queries. We have seen geolocation queries. Now they also have support for date time queries as well. The demo I can show. I will give you access to that. Then multi-tenancy. Okay. Now we talked about the multi-tenancy, I think, in some of the presentations before, which means that actually if you are like 2 companies and there is one infrastructure on the cloud, okay? In cloud you have like multiple companies who have access to the cloud, let's say to AWS. How do you differentiate? How do you isolate one company's data to another company data? So how it is defined is the context broker supports the multi-tenancy. So you can define a FIWARE service, what we call in the multi-tenancy approach, and you can segregate or isolate the one kind of data with another type. So you can use, let's say, this kind of hierarchy. You can have mid-rate, gardens, and district. So you can have, let's say, a tenant for mid-rate, or you can have a tenant for, this is from Spain actually. So you can have, let's say, one for France, like that. So you can differentiate this using, you can create this kind of hierarchy, and you can organize your data in form of FIWARE service and FIWARE service path. So context broker, the FIWARE also has support for some things like freeboard.io. So it's openly available. You can just open it. So if you want to visualize without writing a source code, you can also use these kind of tools available, which are directly compatible with FIWARE. So you can just plug in and play with that. FIWARE also support CARS implicit, so cross object. So you can enable or disable CARS if required, which is like cross origin requests. So if you want to restrict it, you can restrict if you want to enable or disable it. I think that's all for this presentation.